Hi, welcome. How are you? Okay, take care of yourself, Sanu. Dolla. Okay, take care. Now, in the previous classes, you've understood what is rational numbers, what is irrational numbers, whole numbers, integers, all that representation of it. And also found out when your decimal number is given to you, you can find out whether it is a rational number or an irrational number. For a rational number, it has to be either terminating. Okay, the rational number should be terminating given fraction. You could rather say, to qualify a given fraction, to qualify as a rational number, it has to either terminate when you go by, or it has to recur, non-terminate but recurring either as a single digit or as a group of digits recurring. It qualifies to be a rational number. And if it is not recurring and not terminating, such type of fractions qualify to be, or such type of numbers, or rather say, qualify to be as irrational numbers. Right now, many a times you get confused of pi. Let me talk of pi. Pi, in for our ease of calculation, we take it as 22 by 7. But if you take pi as 22 by 7, it is in a perfect p by q form. And if we go by division, if you go dividing 22 by 7, you get a rational number itself. For example, I'll show you. Just hold on. Yeah, if I start dividing 22 by 7, see, I get 7 3s are 21, then 1 remainder 7. Okay, I put a point, add a 0, 7 4s are 20, 3 0, 7 4s are 28, again I add 2 remainder 0, 7 2s are 14, 6 remainder 0, okay, 7 8s are 56, 4 remainder 0, okay, 7 5s are 35, 7 5s are 35, then again 5 remainder 0, add a 0, 7 9s are 49, then you get 1 again, 7 0, 7. So you can just see the same series after this gets repeated. So the same series, that is 10, here you get 10. Initially you started with 10 here, when you got 1 remainder, you started 10. Now here also you see you get 10. So after that again 3, 30, you have 30. Then if you see 20, you have 20. So you can just see that 3, 1, 4, 2, 8, 5, 7, this is recurring. This much is recurring. So when you say 22 by 7, it is just an approximation which we have used as a value of pi, but this is not the value of pi. This is only for the calculation, for the ease of calculation we have used, we represent, or we take pi as 22 by 7, but value of pi is not exactly 22 by 7. So pi does not qualify to be a rational number, because I'll tell you the value of pi exactly is, okay, the value of pi is 3.141592653589979 and so on. You see, nothing is repeating here, right? Nothing is repeating. Oh, it is not terminating, nor is it recurring. So that is why pi qualifies to be an irrational number. So do not get confused, because when you write pi as 22 by 7, when you write pi as 22 by 7, it is not, 22 by 7 qualifies to be a rational number because of this calculation, but that is not the exact value of pi. So it is only for the ease of calculation. When you calculate something, you take it 22 by 7, because 3.12485 is somewhat close to this. 3.142, this 5 is rounded up. If I round it up, I will get it as 3.142. So that is why, for the ease of calculation, we use value of pi as 22 by 7, but 22 by 7 is a rational number, but pi is not a rational number. Okay, pi is not a rational number, because when you take pi, the exact value of pi is equal to 3.14259292653, so much it keeps on. So you find there's nothing, no repetition here. The digits are not repeated, it keeps on different digits every time. So pi is not a rational number, but 22 by 7, when you use for calculation purpose, it is a rational number, right? 22 by 7 is a rational number, but it is not the exact value of pi, right? Now let us try to find out how do we identify irrational numbers from a given number. You have a decimal number given to you, or any number given to you, and you find out whether it is a rational number or an irrational number. And as I told you, a rational number, when you divide it, either you get a remainder as 0, or it is non-terminating and but recurring, either as a single digit recurring or a group of digits recurring. Okay, so it qualifies to be a rational number. But in case of irrational numbers, it is non-terminating and non-recurring. How do you identify it? I'll show you that. Now let us take root 2. Find out the value of root 2 by the division method. So we know the division method. We write this 2 and 1. Okay, so 1's 1, 1, right? Then you add here 1, you get 2. You have 2 zeros which you bring down. Okay, you add your zeros. Okay, that's fine. 2 zeros you bring down, then you find out, you know what it is, how to do the division method. Find a square of which comes exactly and below this. So I'll take this 4 4s are 16, 9, 4 2s are 8 plus 1, minus, so I get 4. I add 4 here, I get 28. Then I bring the 2 zeros, add down. Right? This is how you do the division method. And you just see 1s. Here you add what? Sorry, 1. 1s 281. This is 9. Okay. So 9 minus 8, 1. 3 minus 2, 1. Okay. Here you added how much? So you have to add 1 back again. So you get 282. Add 2 more zeros. Add 2 more zeros. Now what will you do? So you have so 4 times. Let us try. Or okay, so is it 4 times? 4 4s are 16. 1. 4 2s are 8 plus 1, 9. 4 8 4s are 32. 2, 3 to be carried out. 4 2s are 8, 8, 9, 10, 11. So you are left with 604. Then you add again 4 here for this. So you get 2828. Bring 2 more zeros down. Now in this, how many times does this number go? How will you identify? So you again see that you have 28 and here 6040. Now this will go, say 2 times 2, 2. Okay, so this comes to around about 56,000. So 56,564 and so on. So now if you see this division does not end, nor this does not end, and here none of the digits is recurring. It is different. Here you get first 4, then you get 1, then you get 4, then you get 2. I don't know again what all numbers you get. So square root of 2 is 1.4142, and so on and on and on. It is not recurring. So this represents it is non-terminating. It is not terminating. It is not terminating. Okay, and not recurring. It is not terminating and not recurring. That is why this digit is a irrational number. This number is an irrational number. That is root 2 is an irrational number. So now you have understood that a rational number, you have it as the denominator. I mean, when you divide the numerator by the denominator, you get the remainder as 0, or the remainder, you don't get a remainder, but it does not terminate, but it repeats, digits repeat, recur, either as a single or a group of digits recurring, so it qualifies to be a rational number. Here in an irrational number, when you divide it, either it is not terminating, the division does not terminate with a 0, nor does the digits recur after the decimal point recur. So there is no recurring or repeating of the digits. So such type of numbers where there is no repetition of the digits after the decimal point, such sort of numbers have been identified as irrational numbers. Okay, so if I give you some numbers now, you have to identify and tell me whether they are rational or irrational. Okay, be truthful to yourself and tell me whether they are rational or irrational. Just hold on, I'll show you the numbers. Now you have this number 1.362. You have now this number, when you see it, what does it do? Show after the decimal point there is a termination. That means there's no dot dot dot, there's no continuation, so it indicates that it has terminated. So when it says it is terminated, it really qualifies to be a rational number, right? R, or I could rather say that it is a Q also for rational numbers, but I'll take it as R right now. Now 1.392, which has a bar on 92. Since these two digits are recurring, the ending two digits are non-terminating, but there's a recurring of digits. So again it qualifies to be a rational number. Now if you just take the next number, 3.7364 dot 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 dot, that means this number has not terminated and it is not even recurring because there is no bar on it. It is not recurring. So this qualifies to be a irrational number. IR, I'm just writing it as IR, it qualifies to be a irrational number. Now let's see 5.763 with a bar on the top. When you see the bar on the top, that means, what does it mean? This number 3 is repeated. So there is recurring. It is not terminating, but there is a recurring of the digit. Hence it qualifies to be a rational number. 9.62, a bar again, or wherein this digit 62 is repeating. So again it qualifies to be a rational number. 0, in fact 0 can be written as 0.0. That means again it is terminating, it is a rational number. You have 1.0, that means it has terminated and it is not recurring. It has terminated. Obviously there is no question of recurring when it is terminated. It's rational number. You have 11 can be written as 11.0. So when I say 11.0, it is terminated and recurring, hence it is rational number. So it is only irrational number. You can just see this number digit. This number is an irrational number because it is non-terminating by dot 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 dot, and there is no bar on the top. That means it is not recurring, and hence this digit, this number, is a irrational number. This is what you have to keep in mind, that if a number is not terminating and not recurring, it qualifies to be a irrational number. Does not qualify to be a rational number. For a rational number, it should terminate or it should be recurring, right? So, or it can be both. It cannot be both, right? It cannot terminate as well as recur, right? So right, you're perfectly right. So either it should be terminating or it should be recurring to qualify as a rational number. For irrational number, it should be non-terminating, it should not terminate, but it is not recurring also, it is non-recurring. So in these cases where it is not terminating and also not recurring, it is qualifies to be a irrational number. So I hope with the small exercise that you have done now to identify from a given set of numbers which is a rational number and which is an irrational number, you can easily find out with these concepts in mind. Okay, hope that is clear to you. Because my classes are just 15 minutes classes every day, I stop it here. I'll continue with the exercise that we have to do. Okay, we have to do an exercise, so we'll do the next exercise in the next video. Thank you very much. God bless you. Take care of yourself. Have a great day ahead. Bye.